should have it wet.
I don't like
Oh, well, goodness. Yeah. Call the ambulance on her, I tell ya. And actually, we're going to have several things to glue in, so you just want, if you want to wait until the end, we can glue it all in at once.
Will we get to know our test scores tomorrow?
It'll take me a while.
Are we working on vocabulary today? Okay, yeah. We're working on vocabulary today.
Okay. So we are going to go through these terms. We are not going to use all of them today, but we're going to go ahead and get our vocab done for this whole unit so that we can glue it in and have that as a reference. Slope measures the steepness of a line. Steepness is how steep the line is. So you can either have a line that is very steep on a graph, or you can have a line that is very flat on a graph. And all of that is measured with slope. There are multiple ways to calculate slope. We're going to write them all down today. We're just going to get all of our notes on this, and then we will talk about these in more detail. One way to calculate slope is rise over run. John, come on, you should be taking notes right now. You can worry about gluing later. Another that we are actually going to use today is a formula that is off of the formula chart. M is the letter in the equation that we use for slope. If you look at this equation, y equals mx plus b, we are going to get very familiar with this equation. M is your slope. So one way to calculate slope is with this formula, y2 minus y1 over x2 minus x1. Now do make note of the fact that y's are on the top. X's are on the bottom. If you flip those, you will miss it. Okay, it is very important that you get things in the right position, and we'll talk more about that. This may look familiar, and if it doesn't, it will soon. Okay. It is a little graphic, and we're going to watch a video here in a minute, and you're going to see this graphic in the video. Here's what I want you to put. I want you to put a plus sign here, a negative sign here, a 0 on this flat surface, and here you are going to write undefined. And like I said, we'll talk about it more, so just go ahead and copy it for the moment. Okay, the next thing is rate of change. It is the ratio of change in variables. Basically, what we are talking about when we do a comparison, or when we do a ratio, is we are doing a comparison of two things. Okay, we are comparing two things, and it is typically expressed as a unit rate. The word unit means 1. Okay, if we talk about a unit tile in algebra tiles, the unit tile represents 1. When we talk about unit rate, we are comparing to 1. Here's some examples. Miles per hour means how many miles can you travel in 1 hour? If I get on the highway and I set my cruise control at 75 miles per hour and I don't touch it, in an hour I should go 75 miles. Okay, that's my unit rate. I could also do something like cost per shirt, which would mean what is the cost of one shirt? That is the unit rate, and this would also be considered the rate of change, which basically means how fast does one of these change in comparison to the other. Now, these last two we're really not going to reference today in the lesson, but I'm going to go ahead and give you the notes for it. We're going to talk about y-intercept and x-intercept. The y-intercept is the y value of the point where the line crosses the y-axis. And in every case, the x value of that point will be equal to 0. I'm going to give you an example. We're going to draw a really simple coordinate grid here on the right and label our axes x and y. It's axes if you're talking about more than one. If you just talk about one, it's the axis, but if you talk about more than one, it's axes. And then what I'm going to do is I'm going to put a point on my y-axis, and I'm going to draw a line that goes through that point. Now remember that I told you the y-intercept is the y value of the point where the line crosses the y-axis. If you look at my arms here, here's my y-axis. Here's my line. All I'm looking at is where do those cross, okay? Where do the lines cross? Where do they touch? And it is right here. That is your y-intercept. So in this example, I'm going to say this point is 0, 2. Okay, that would be the ordered pair to get to here. I'm saying that this is at 2 on my axis. And when you think about, I'm going to go back to this equation that I wrote at the top. Y equals mx plus b. This right here, and notice that I got the sign and everything, that is where my y-intercept goes in my equation. So because this point that I pointed out to you is up here in a positive place, I would have mx plus 2 would be what I would write. You don't have to write that, I'm just showing you that. If my point had been down here, my equation would have been y equals mx minus 2. Does that make sense to everybody? Okay.
Yeah.
So because this was at a positive, I get plus 2, and because this is at a negative, it would have been minus 2. I don't need to do plus minus ever. We don't need that combination of signs, so we just use whichever one matches the point. The x-intercept is the x value of the point where the line crosses the x-axis. Now the x-intercept has actually lots of names that they can be called. They can be called roots, solutions, and zeros. Now, on the y-intercept, remember that I told you the x value of that point? If you look at this one, the x value is always 0. On the x-intercept, it is actually the y value that is equal to 0. So they flip-flop on those. We'll draw that our little graph again here with x and y. This time, I'm going to give you a point on the x-axis, and we're going to draw a line through it. So notice the x-intercept is where does the line cross x? And it's here, so this would be my x-intercept. And the value of that point, the ordered pair, would be 2, 0. So notice that in this case, the y value is 0. So they're the exact opposite as far as how we think about them.
Wait, so are points, like for this, ever going to be somewhere that's not along the y or along the x?
It never would for a y-intercept or an x-intercept. I mean, we'll talk about lots of points
Well,
on the
yeah,
graph.
I know. That's what I mean. Like, for if you're trying to find an x-intercept, will the point ever be somewhere that isn't on the x-axis?
Okay, the x-intercept is always going to be located on this line. The y-intercept is always going to be located on this line. Okay? Does that make sense to everybody? Because that's where does the line cross y, and this is where does the line cross x. Now, potentially your line could not cross. When would it not cross the y-axis? When it's straight up and down, right? If I had a line like this, that's the only type of line that's not going to ever cross y. What's the only line that won't cross this axis? This. So that's going to be the only time you're going to see that. But for what we're doing and what we're talking about today, it should be crossing them. Okay. So you can just set that to the side, and I'm going to give you your next notes page. Okay. So what did we just say that slope was? Slope measures the steepness of a line. Today we're going to use two methods to calculate slope. The first one is going to be rise over run. The second one that we are going to use today is going to be our formula that I gave you, and it looks like this, and nobody should be gluing right now. I already told you that we'll glue after. This is y2 minus y1 over x2 minus x1. Each one of those x's and y's is actually related to a point. Today's lesson is called Slope from Graphs and Points. When we have a graph, we are going to use rise over run. When we have 2 points, we will use this one. So it is there's more than one way to calculate slope. It's good to have all of these in your tool belt, right, that you can pull from. Now, the first video that I'm going to show you is going to change your life. Are you ready? You may have seen it before, but if not, you'll remember it forever. So here we go. Yep.
Welcome to the Adventures of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him, and he'll teach us some important aspects of slope. This is the course he's skiing today. What he says will teach us about slope. Always remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive. Puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain, but now he can look forward to the downhill. On the way down the mountain, he says, nice, negative, nice, negative, nice, negative. And now, after the downhill, he's in for the hardest part of the ski route, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. As he finishes the flat part, he doesn't see well ahead, and all of a sudden he comes to the edge of a cliff. It's straight down. He finds a slope that is straight down, and so frightened is he that he says the worst curse word possible in math and in algebra. Undefined. This has been the adventure of Slope Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said, puff, puff, positive. On his downhill run, he said, nice, negative. On the long, flat part of the course, he said, this is zero fun. And finally, when he went over the vertical cliff and straight down, he yelled the worst curse word of math and algebra. Undefined. The uphill is a slope with a positive number. The downhill is a slope with a negative number. The flat part is a slope of 0, and the straight up and down or vertical part is undefined. This has been The Adventures of Slope Dude. Special thanks to Kim Yui for inventing Slope Dude.
So you have to say undefined.
So that was the video that you said would change your life.
Change your life, right? I can guarantee you guys, listen,
First.
I do not know a better trick for remembering all the different types of slope than Slope Dude. It may be goofy, but I guarantee you it sticks in your brain, okay? And so there will be times where I'll say, draw your Slope Dude graphic, right? And that's that little one that we drew on our vocab page. And so things I want you to remember that are really important from that, remember that you always come in from the left, and that's really important. So you look at your line on a graph like you were reading a book. You go uphill, downhill, you can go straight across, and then you go down. When he goes uphill, you're always going to have a slope that is positive. When he's going downhill, so notice if I'm going left to right, I would be going downhill. Your slope would be negative. This is 0, and this is undefined, right? You have to add that little bit so that you can remember that. Slope Dude's great. It's very goofy, but it really does help you remember all the different
That
kinds
guy's
of
voice kind of reminds me of like one of those really, really old movies.
Yeah, he's kind of dry, isn't he? He's not the most exciting. Okay, so let's take a look at this. So let's look at the first one here. What would Slope Dude say about this graph?
Puff.
Puff, puff, positive. Yeah. The reason that he says puff, puff, positive is because he's going uphill and he's breathing hard because it's hard work. If you've ever been snow skiing, going uphill is not very much fun. Okay? It's very hard. Yeah, but you sometimes, trust me, I've been skiing and I'll never forget one time when skiing. I met my husband, he's from Denver, and so he had skied since he was 4, right? Long time, and he was a super good skier. Well, I was an okay skier because I've always been an okay athlete, not a great skier. And anyway, my brother came up to ski with us. And of course, my brother and I, we just like to ski as steep a slope going downhill as we can, as fast as we can. That's what we thought was really fun. And so we got up to the top of the hill, and I don't even remember what happened, but a ski goes, my husband, who's a really good skier, one of his skis popped off, and it went over the hill, right? Turns out that was like a triple black slope that it went over, which means it's a super tough slope. And my brother, who's only a mediocre skier, goes, I don't get it. And he goes shooting over the edge, right? And then we look down there, and of course his skis are off, and they're spread out everywhere, and my husband's skis down there. But if you go down a slope and you have to get back up, you're going to be saying puff, puff, positive, okay? Trust me. So not a whole lot of fun. Anyway, we had some real ski adventures. I'll have to tell you about some more of those someday, but not today. Okay, how about this one? Nice. Negative. And usually what I will do is I'll just put a negative sign out beside it like that if I recognize that it goes downhill. And I might also put a positive sign beside it if I notice that it's going uphill. Now, take a look at this one. What would Slope Dude say about this graph?
Zero.
Zero fun. I'm just going to put a 0 right there. Now, I want you to look at what I'm going to do here, and I'm going to have you do the same thing. I'm going to go over to -2, and I'm going to put a dot on my graph. And I'm going to go over here to +2, and I'm going to put a dot on my graph. And now let's think about the fact that we are going to be using rise over run, because I told you that if we have a line on a graph or we have points on a graph, we're actually going to use rise over run. Stop saying it, please. I'm going to connect those, and I'm going to think about, to get from one point to the other here, do I rise any? No. So my top value is going to be 0. How much would I run to get from point to point? 4. Put that in your calculator. Yep, 0 divided by 4. Put it in your calculator. Put it in your calculator. Just do it. Just be with me to today because I guarantee you there's going to be some interesting stuff. Okay? Now, notice when the 0 is on the top, that's what I get. If you did 0 divided by 4, it should have given you 0 in your calculator. Look at this line. Let's do the same thing here. Let's go up 2 and put a dot, and down 2 and put a dot. And connect your dots. That's going to be the line that we're talking about. What is my rise? 4. 1, 2, 3, 4. What is my run? 0. Put that in your calculator. Error. But look at what it says beside error. It says divide by 0. Guys, you can't do that. Okay? And so what we say when we are dividing by 0, if you get that error message, that means that line, which is a vertical line, remember that this is vertical, has a slope that is undefined, okay? It's not a very straightforward thing in math. So this is undefined, this is a vertical line. Remember that this is a horizontal line. If you don't know those, write those down. Bless you. Please don't do that to calculators, guys. That's real rough on the keys. That's how we tear them up by doing it. Okay, let's set our calculators down. We don't need them for the moment. You guys are getting a little rowdy. So, I'm going to move on. And I'm going to show you another little video. Now, this one may not change your life, but it will give you something to sing for the rest of the day. All right, here we go.
I know, I'm already feeling it.
Rise up or run out. We mapping grab to the triple R sound. We're talking points and slopes, axes and origins. Y intercepts and quadrants all for them. Rise up, run out. We mapping grab to the triple R sound. We're talking points and slopes, axes and origins. Y intercepts and quadrants all for them. The 4 quadrants start from the top and right, counterclockwise from the positive X to Y. You go around, hit the 2 and then 3, bottom left negative. Remember that, please. You got a single point on the X, Y grid. There's a single pair of values telling you where it is. This X coordinate goes from side to side. The Y follows a comma to define the points. A straight line between 2 points is a relation. You can represent it with a linear equation. Y equals M times X plus B. If you want to know the variables, listen to me. M is the slope, that's rise over run. It tells you how steep the line is going to become. B is the intercept, that's how you assess the point at which the line goes through the y-axis. Rise up or run out. We mapping grab to the triple R sound. We're talking points and slopes, axes and origins. Y-intercepts and quadrants all for them. Rise up, run out. We mapping grab to the triple R sound. We're talking points and slopes, axes and origins. Y-intercepts and quadrants all for them. Say you got a job and you're earning your pay. You start with $50 and get 9 every day. If you wanna know over a year how much you get, calculating that graph might be your best bet. On the X, you measure it one day at a time, and your money gets tracked on the vertical Y. Now you got some, and you ain't even worked yet. $50, put it up, that's your Y-intercept. After the first day, you got 59. Now you got 2 points, you can start drawing a line. The slope of that line, remember, rise over run. It's dollars over days, and you got none over one. Remember B, I think that's where we started at. $50 up on the graph, the Y-intercept. And you know Y equals MX plus B. Now you got Y equals 9X plus 50. Rise up or run out. We mapping graph to the triple R sound. We're talking points and slopes, axes and origins. Y-intercepts and quadrants all for them. Rise up, run out. We mapping graph to the triple R sound. We're talking points and slopes, axes and origins. Y-intercepts and quadrants all for them. Rise up.
Okay, now I expect you to say, rise up, run out. Right? Because he's got that every time in there. Cracks me up to watch this. I've seen this a whole bunch of times. I always go home after this day and I sing it at home, and my husband is like, what are you doing? Right? It's kind of crazy. So we are going to use rise up, run out. And watching that video, right? So you should always remember that.
Yeah.
So here's what we do. You notice on this graph, we just have a bunch of points. Remember that I told you how many points do you need to find slope? 2 points. So notice in the first case, we're going to find the slope between points C and D. The first thing you do is you connect your dots. Now, the second thing that I always do is say, what would slope dude say about that line?
It's a
Nice negative. I'm going to put a negative sign there and there. And I usually put it out beside my line so that I don't forget when I start writing my slope over here. Now, guys, listen. Slope is always written as a fraction or an integer. What's an integer? Positive or, good, Kiara, a positive or negative whole number. Now, because I said it's written in a fraction, improper fractions are okay, all right? I could end up with something like this, and I'm not going to do anything with it. I'm going to leave that alone. We're not turning them into mixed numbers, so make note of that, okay? So what we do, once we have our line drawn, is we're going to do rise. And the way we do that is I usually from this point go up for my rise because that's what I think about what that word means. And I go 1, 2, 3. So notice where I'm rising to is straight across from this point, and then I run 1, 2, 3. What does this simplify to? Negative 1, and you've got to have that. If you leave that 3 over 3, I'm going to count it wrong. If you put 1 over here and you don't bring the negative over, it will be wrong. So you need to make sure that you're being careful. This sign has to come over here, and that you always want to simplify. If you're unsure, you can use your calculator and hit math enter, and it'll turn it back into a fraction for you. Now, I want you to look at this. What shape, by drawing this, did I make?
A triangle.
What kind of triangle?
A
A
right triangle.
right triangle. If you're doing this correctly, it will make a right triangle every time. If it helps you to draw the lines first, do that. It is totally fine. Okay, so let's look at BC. So I draw my line here, and I think what would slope dude say about that line? Okay, so I'm going to go ahead and put my positive here, and I'm going to go ahead and put it here just while I'm practicing this. I want to make sure I don't leave a sign off that I need. All right, I'm actually going to go ahead this time, and I'm going to draw my right triangle. It doesn't hurt to do that, and that helps me be able to visualize that. For some people, they may need that step. Okay, here's my rise. I go up 1, 2, 3. That's the top part of my fraction, and then I'm going to run. What'd you get for your run? What? 6. Will this simplify? To what? 1/2. Very good. A lot of people miss that because they'll say 2. They just automatically see the 3 and 6 and they think, oh, it's 2. Remember that if this fraction had been this, what would that simplify to? That would be 2. The bigger number on the top, it would simplify to a whole number. This only simplifies to 1/2. All right, let's do the next one. E and F. What would slope dude say about that line? Undefined. We're going to write that out here. Okay, A and E. Now, would this be considered a flatter line or a steeper line? Flatter. It's really nearly flat. What would be the flattest line on a graph? 0 is the flattest. What would be the steepest line? Undefined. The closer a line gets to this, the bigger the number it's going to be when you're looking at the actual slope. The flatter it is like this, the closer that number is going to be to 0, okay? So, once again, I'm going to go ahead on this one and draw my right triangle, because if you notice, it's not 0. It actually has a very small rise to it, but a long run. Now, what would Slope Dude say about this line? Positive. So I'm going to go ahead and put my positive sign there and there. So go ahead and count it out. All right, what's the rise? 1. And make sure you count carefully. Now remember, you never count where you take off. So what'd you get for your run? 11. And that's your slope for that one. So this number is very close to 0. That's about as flat a line as you can get unless you're in the halves or somewhere, okay? All right, B and D. What would Slope Dude say about that line? 0. That is 0 slope, 0 fun. And I'd like you to do BF, please. Make sure you're asking all the relevant questions that you need to. Okay, so what'd you get for your rise? What'd you get for your run? What would Slope Dude say about that line? Make sure you have that out there in front of it, okay? If you don't have the negative out here, it would be incorrect. So make sure you get that negative. Now, any questions so far? Then let's move forward. So these lines have no dots. So here's what I want you to be thinking about, okay? I'm gambling. I would guess that most of you have either done one of two things. Maybe you have shot, a gun or something that has like a sight on it, hunting. I know Miss Raymer does lots of hunting, so she always uses that example. I am not a hunter. Or you played a video game that has crosshairs, right? Have you done that? So do you know what I'm talking about when I say the crosshairs?
Yes.
Okay, does everybody understand that? So when you look up here in this upper corner, I'm going to draw some crosshairs. And I want you to look where I'm drawing them. Right where the lines intersect. And it's really important that you understand that concept of where the lines intersect is where I'm going to put a dot. I don't want my dots to cross anywhere but where those two lines actually cross. So when I look at line A first, what would Slope Dude say about that line? That it is a negative. I'm going to put that out beside there. And then what I'm going to do is I'm actually going to make sure I get 2 dots on there. Here's the process I use. I start at the top of my line and I go down. Could I put one here?
No.
Could I put one here?
Yes.
Yes. So I put my first dot right there. From that dot, I'm going to go until I see the next one. I want my dots to be as close together as possible. So could I put it here? 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 Here?
Yes. No.
Here?
Yes.
Yes, okay? Now, I try to get them as close together. The reason I do that is I'm not going to have to simplify my fraction if I get mine nice and close, okay? So here's my right triangle. What's our rise? 2. What is our run? 1, 2, 3, 4, 5. And that would be the slope of line A. Have to have the negative sign on front of it. All right, let's look at B. What would Slope Dude say about line B?
0.
Okay, this one is 0. Put that over here. All right, let's look at line C. See if you can place some dots on C. You only need 2 dots. What do you notice when you start putting dots on C?
They could go anywhere.
They could go pretty much anywhere, couldn't they? So I'm going to go down here and I'm going to put one here and one here. close together. What would slope dude say about line C? It's positive. And here's my little right triangle. So what does my rise? What is my run? And what does that simplify to? 1. Positive 1. Now I want to show you something. You do not have to draw this on your graph, but I want to show you this. So let's say that I didn't find the dots that were closest together. Okay? So from here I'm going to go up 2 more, and I'm going to make a right triangle. On that one, what's my rise? 2. What's my run? 2 over 2 simplifies to 1. Okay? From here I'm going to go up 3. On that triangle, what's my rise? What's my run? What's 3 over 3? 1. Okay? So now make sure that you're giving me the right answer if you're doing it. I'm going to do a really big one. Okay, let's just say that day I was not thinking straight and I ended up with this one. So let's look at the rise. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. What do you notice?
It's always still.
Okay. Does it matter what size triangle I draw? No. That line has got a slope of 1. It does not matter if I draw a tiny triangle or a huge triangle. Every triangle that I draw on that line, because the ratio is the same, 2 over 2 is equal to 3 over 3 is equal to 8 over 8 is equal to 1 over 1. Does everybody see that? Okay, so that's the ratio of my sides. The rise to the run is going to simplify to 1 every single time. Okay, okay, how about line D? Undefined. Okay, any questions about slope of a graph from a line? Or slope of a line from a graph, I should say it that way. All right, so we're going to look at a different method. This is method 2. This is on the back of your sheet. This is going to use this formula. Now, I'm going to teach you a couple of tips for working with this formula that I think will be extra helpful. At least I find them extra helpful. And you guys, I've been doing this for, it feels like 100 years. And I still do these same steps, okay? So I'm going to show you what I'm going to do. Every single point that we work with, remember, a point has to have an X and has to have a Y. That's an ordered pair. Has to have both of those. So the very first thing I do is I label my points X, Y, X, Y. And what I want you to notice is this is point 1 and this is point 2. Now, not every time are you going to have to write point 1 and point 2, but I'm showing you that so that you can see how I actually label my points. Because this is point 1, I'm going to go up here on my X and Y and I'm going to put a little subscript 1 on them. Above point 2, I'm going to do the same thing, but I'm going to put a 2 on each of them. If you will do that first, it takes anything that's difficult out of this problem. The next thing I do is I always draw my fraction bar and my 2 subtraction signs. That's just part of the formula that I'm bringing you down. Here's the way you work these problems. Notice that the formula says y2 comes right here. Look up there. What value is in the y2 spot? That goes here. What value's in the y1 spot? What value's in the x2 spot? And what value's in the x1? That one I'm going to put in parentheses because notice I ended up with minus a negative. Let me just tell you, I do this part that I did in green right here so that I do not lose the subtraction sign. So we're just going to work it out. What's 8 minus 3? And what happens here? Those are going to cancel and become a plus sign. 2 negatives turns into a positive. So 4 plus 2 is, and that's my slope. Okay? So let's do the next one. Same thing. M equals, I always want you writing your formula. And I always want you to label your points. So what should I put above my first point? X1, Y1. What should I put above my second point? X2, Y2. And if you'll do those two things, like I said, it really makes these problems really easy. All right, what goes in Y2? What goes in Y1? What goes in X2? What goes in X1?
No,
7. 7. All right, what's going to happen on the top? Okay, so those are going to be a plus. What's 2 plus 6? Now, here on the bottom, I have same signs. What are we doing at same signs? Add and keep the sign. So I know this is still going to be a negative. What's 5 plus 7? Now you guys look. It looks like my negative is on the bottom, but when I simplify, I can actually bring my negative out in front of the fraction. I know Ms. Raymer showed you that on an earlier video. And what is this going to simplify to? 2/3. That would be the answer that I would be looking for. Because this divides by 4 and this divides by 4 to give you your simplified version. Any questions so far? Okay, I want you to try the next two. I want to see the same process. I want you labeling your points and I want you writing your formula. So I'm going to work them up here while you guys are still working. So 2 minus 2, 5 minus 1. I'll plug everything in. 16 minus 8, negative 2 minus 2. So what did you get right here when you simplified? 2 minus 2 is? 5 minus 1 is? Uh-oh. What happens when you put that in your calculator? Better put it in your calculator if you're not sure. It's 0. Now, I want you to write this down. If it had been 4 over 0, then it would have been what? Undefined. Make sure you put that on your notes page. Okay, when we simplify this, we get 8 over negative 4. What does that simplify to? Negative 2 would be the correct answer for this one. Any questions on using the slope formula? Okay, I gave you one little thing that we're going to finish up the lesson with. It is a graph sheet, so get that. And what I want you to do is I want you to write down these points. And we're going to graph those points. What directions does this ordered pair tell me to do? What does that tell me to do? How am I going to get to this point?
Go to the left 2.
Left 2.
And up 3.
Good, that's exactly what I'm looking for. left 2, up 3. What does this order pair tell me to do? Right 4. Then what? Up 8. 1, 2. So if we actually were given a graph, we could work it like this. We're going to do our rise over run. What would Slope Dude say about this line? Positive, okay, and we're going to do our rise over run. So 1, 2, 3, 5. What's your run? Okay, I want you to do the same thing with this one. Now I will tell you, especially when I have points that are far away from each other, I typically always draw my right triangle. It just helps me get a better count. What would Slope Dude say about this line? Nice, negative. This is definitely a negative. What's your rise? And your run? No. It is 12. If you miscounted, you will miss that. You got to be real careful. Is that simplified? No. What's that going to simplify to? 2/3. I want to show you something. So let me go back to the notes that we just did and look at the top 2 problems. Notice how these points were the same as those points. Did we get the same slope? Yes. These points were the same 2 points. Did we get the same slope? Yes. Either method will give you the same answer. Just depends on whether you have a graph or whether you have 2 points. I'm going to show you.